unit deals with the triangle. You guys thought you knew a ton about the triangle. Oh, I know what isosceles is. There's 180 degrees in every triangle. You know nothing. All right, until after this unit. You know nothing yet. All right. First thing I want to cover is what are called concurrent lines. Concurrent lines. 3 or more lines all intersecting at the same point. Can you draw that into the square I gave you, please? 3 or more lines all intersecting at the same point. Just not intersecting each other, they intersect at the same point. What are we looking for? The one that everyone picked up as they came in? Yes, right over there. And don't let me forget, I have an assignment sheet for everyone at the end. Okay, everyone have 3 or more lines intersecting at the same point in the box up there. All right, that point, pretty special. Wherever they all happen to intersect, that point's called the point of concurrency. I know, the mathematicians are pretty clever, huh? Concurrent lines, and then you have a point of concurrency. So that's the point where all 3 of those lines intersect. Questions so far? All right, now we have a third new term called circumscribed. Circumscribed. What that is I have a circle that is drawn around a triangle. So everyone in that box right now, draw yourself a triangle. Draw yourself a triangle. Doesn't have to be anything fancy. Now what you're going to do is circumscribe a triangle around it, meaning you're going to draw a circle around your triangle so that each vertice, how many vertices does a triangle have? Each of those 3 vertices touches the circle. We say now that that circle is circumscribed. It is on the outside. It is circumscribed. You can just freehand it, some of you. It's fine. I don't need anything great here. Plus, you might be there a while if you try to do it with the compass, because you need to find the exact point to put it on your paper to do so. What if I want the circle inside the triangle? Now I say the circle is inscribed. Inscribed. So again, you can draw either one first, the circle or the triangle. But now when the circle's inside, the circle needs to touch each side of the triangle. Okay? It needs to touch each side of the triangle. So when I draw a circle around the figure, I say it's circumscribed. When I draw it inside a figure, I say it's inscribed. Okay? And this could work for pentagons, octagons. I could put a circle inside or outside it. I'm just doing a triangle because that's the unit we're in. Questions on those 4 here? Already loading up on the vocab. Questions on those 4 going? All right. Go ahead and plot triangle ABC, then I will divide everybody into 3 groups because you got some big jobs here to do today. 3 groups. Group 1 is going to be this section today. Group 2 is going to be this middle one, and Group 3 is right over here. All right, your first job. Each group has to find the midpoint of their designated side. All right, so Group 1, you have AC. Group 2, you have BC. And Group 3, you got the midpoint of AB. Now, let's go over this because let's say it wasn't too hot on yesterday's test. Midpoint formula. What goes in between the X's and the Y's? You sure about that? Because about 60% of you threw minus signs in there yesterday. Don't know where that came from or when we showed that. You add the coordinates and not subtract them. Yeah, that was a huge issue yesterday. So go ahead, find the midpoint of your side, please, and be ready to report back on it. You might want to check with people around you. Adding the coordinates, not subtracting them. Wasn't too sure where that came from. Group 1, midpoint of AC. Somebody report back. Midpoint of AC. 4-1. Everyone right now, please call that point D. 4-1. And I'd like you to go over to your graph and plot it, please. Plot 4-1. Group 2, midpoint of BC. 8-2. Everybody, I'd like you to call that point E. 8-2. And go over and plot it on your graph. And Group 3, what was the midpoint of AB? 5-4. Everyone, please call that point F. 5-4, and plot it on your graph. Everyone have the midpoints of each side graphed right now. Okay, next job for each group. Now you're going to find the slope of your side. And then after you find the slope, you're going to tell me what would be the slope of a line perpendicular to it. So let's review this one more time. Slope formula, what goes on top? The y's, not the x's. And because you've graphed it already, you don't feel the need to do this. You could also do, just count, rise over run. It's up to you. Okay, so go ahead with your segment. Find the slope of your line, your side, and then what would be the slope of a line perpendicular to it? Check around you as well. How does perpendicular lines and slopes relate again? Group 1, here we go, everyone. Group 1, because I'm going to have you do a little bit more than fill in the table. Group 1, what was the slope of AC? Negative 2/3, which would mean the slope of a line perpendicular to it. All right, here's what I want everyone's help with now. I need a line perpendicular to AC, so it's got to have a slope of 3/2, but it's got to go through point D. All right, so everyone go to point D right now on your graph. I need at least one more point to do this line, but it's got to have a slope of 3/2 because I want it perpendicular to AC. So where could I go from point D right now so I have a slope of 3/2? Where could I go from point D so I have a slope of 3/2? Up, over, tell me direction here. Up, 1, 2, 3. What do you mean by over? To the right 2. So everybody, up, 1, 2, 3, to the right 2. Line up your straight edge and graph that line in, please. Going through point D. Other than a line, anybody know what we just graphed? We have a geometrical vocabulary term for that. First of all, this line is what with AC? It's perpendicular, and it goes through the what of AC? Can we put the two together there? This is a what? Perpendicular bisector, correct. We are going to do that 2 more times. Okay, we're going to do it 2 more times. Group 2, what was your slope of BC? 3. So what would be the slope of a line we're about to graph that's perpendicular to it? Negative 1/3. Everyone record that. And everyone head over to point E now. I need to make a line that's perpendicular to BC, but going through E. So it's got to have a slope of negative 1/3. So you tell me from point E, how do I graph another point? I could go down 1, right 3, or up 1, left 3. It's your call. You decide. What's that? We good? Straight edge, straight edge, straight edge. Do not freehand this because it's not going to come out to be correct at the end. Another perpendicular bisector. One more time. Group 3. Slope of AB, 1/4. So what's going to be the slope of a line we're going to graph to AB? Negative 4. Yep. So everyone right now, go to point F. How can you get me another point? Down 4, right 1, or up 4, left 1? Your call. And if you've been using a straight edge, you should notice something. So let's go down to hopefully, if we've been using a straight edge, we've constructed all 3 perpendicular bisectors. Are they concurrent? What's concurrent mean again? 3 or more that intersect at the same point. I think that covers it right there. So they are concurrent. And then a conclusion we can make, they are concurrent at the point, and I'm going to need somebody to name that XY coordinate that they're all concurrent at. So what's that XY point that they're concurrent at? They are concurrent at the point. So go back, count your X and your Ys. 29, 5, 3. If some of you thought it was 4, 3, you're making a rookie mistake and not starting at the origin. Okay, if you said 4, 3, you're probably starting from point, oh, never mind, maybe you didn't. You're starting from point A, maybe, I don't know. All right, but make sure you start at the origin. Okay? Questions? All right, final thing we need to do is, that point's got a special name now. Okay? When the three perpendicular bisectors meet, that point they meet at, everyone ready? Circumcenter. It's almost similar to what vocabulary term we talked at the beginning today? Circumscribed. That's when the circle could go where? Inside or outside? Outside, right? I saw a lot of you guys, and this is great tying this all in. I saw a lot of you guys when you tried to draw this here, you tried to put your compass somewhere and do it with your compass. Yes, some of you guys I watched. What was the problem you were having? You couldn't make it work, right? You couldn't find where to put it. Everyone right now, take your compass, go back to your graph, put your compass point on the circumcenter. Put your compass point on the circumcenter. Put your pencil point on one of the vertices. Start drawing around and see what happens. That's the point where you put your compass to draw the circle around it, is the circumcenter. Okay? So what you're doing right now is circumscribing a circle around that triangle. And where do you put your compass point? You put it on the circumcenter. You put it on the circumcenter. All right? I just thought that's not needed to know. I just thought I'd tie that in because I watched some of you try to do it with a compass and you're like, I can't do this because I don't know where to put the point. So now you do. You put it on the circumcenter when we find it. All right? Questions? Okay, I have a question for you because I'm going to harp on this all unit long. Here we go. Who's got 5? 5? All 3 perpendicular bisectors intersect at a point called the what? No. All 3 perpendicular bisectors intersect at a point called the? Okay, well, we got a name for it now. Circumcenter. Everyone good? If I'm talking perpendicular bisectors, you guys are talking circumcenter. That's where they all intersect. Everyone are good there. Well, let's find out. I'm going to be brutal here. Already answered my question. Here we go. 4 now. The circumcenter is where all 3 what intersect? Okay, here we go. Everyone good? Okay, last thing before I get off the perpendicular bisectors and the circumcenter. You got to know a special fact. Talking about put your compass on it and make a pretty circle around it. Okay? Everyone has this diagram of triangle ABC? You at least know all 3 blue lines up here are perpendicular. Now I want you to do this for me. Put a hash mark here and here. Put 2 hash marks on both sides on BC and 3 hash marks on both sides of the line on AB. Now that you know that, what are, in my case, they're black lines on yours, but my case, all 3 blue lines are what? What do I call all 3 blue lines up here? 3. What do I call all 3 blue lines? They're all perpendicular bisectors. Everyone agree? This blue line, perpendicular and it bisects. This one right here, perpendicular and it bisects. Good. Making point O the what of this triangle? 23. Thank you. Circumcenter. Point O is the circumcenter. Everybody all right? So can I go on this new piece now? If O is the circumcenter, or any circumcenter, it is equidistant from the vertices. Equidistant from the vertices, meaning everyone right now, from point O to point B, draw in a dashed line segment for me, please. From point O to point B, draw in a dashed line segment. From O to A, draw in a dashed line segment. And from O to C, draw in a dashed line segment. Those three dashed line segments you just drew in are all what? Congruent. Why? Because they're equidistant from the circumcenter. So OB is congruent to OC is congruent to OA. They're all congruent to each other. So go back to your graph. Go back to your graph right now, everyone. That we did. Can I just get somebody to volunteer a point name for the circumcenter? N? I don't know what that was. So if I call the circumcenter point N, what's it equal distant from? I don't want to draw in more lines, but NA is the same distance as NB, same distance as NC. Everybody good? We're all good there, what it does. Okay, because now what I'm going to ask you guys to do is find it on your own. Here we go. Example 1. Here's triangle ABC. Where's the darn circumcenter? Okay, everybody stop. All right, because this is usually where panic mode sets in when I unrelease the ropes and let you go on your own. First thing goes through my mind. I see, okay, you want me to find the circumcenter. That's where all three what should be intersecting? I'm finding the circumcenter. What are all three what lines should intersect? So I'm thinking, all right, I need to draw the perpendicular bisectors for all three sides. Everyone see? All right. I see, okay, you want me to find where that point is, circumcenter? I need to find the perpendicular bisectors. All right, well, it's not too bad on this triangle. We don't have to do all the work we did on the last one. Let's take BC. What type of line is BC? Please don't say straight. Type of line is BC. It's horizontal. So ready? Perpendicular. What type of line is going to be perpendicular to it? Vertical, and bisects tells me it has to go through the middle, halfway. So can you graph that real quick for me? A vertical line that goes through BC halfway. One perpendicular bisector down. 2 more to go. Right? Because we got to do all three and see where they intersect for the circumcenter. What's another easy one to do? AB. What's AB? What type of line? Don't say straight. Vertical. So what's going to be perpendicular to it? Horizontal, bisecting. It's got to go through the middle. Okay. 2 down. Whew. Everyone ready for AC? It's going to be kind of like the graph we did at the beginning, right? We got to find the midpoint, slope, do the negative reciprocal, right, and graph it from there. Do I need to do all that work? Let's think about this, honors kids. Do I need to do all that work? Don't I already know where it should intersect? If these two lines intersect right here, isn't that where the third perpendicular bisector should intersect? So let's save us some work. We're done. As long as we're confident in our abilities on these two, we know where the circumcenter is going to be. And the point of that circumcenter, I'll ask somebody here in a second. Does that make sense to everyone that I don't need to do all three? As long as you've done the first two correctly, you know where it's going to intersect. And what's that point? 21. What's that point? 5, 5. This is what I meant before. If you said 4, 5, you didn't go from the origin. You started from point B. Common mistake. Common mistake. Start from the origin, everyone. Origin all the time. Questions here? Okay, I still have a lot more. 14. 14. Who's 14 in the house? Okay, here we go, Maya. The circumcenters were all three what intersect? Perpendicular bisectors. Good. 27. Do we have one? Nope. How about 9? Do we have a 9? The circumcenter is equidistant from the what in a triangle? What's the special fact? It is equidistant from the... I need more than... So here's the circumcenter. It's equidistant from what in this triangle? Okay, what do we call them, though? I'm going to make you work for this. Equidistant from here, here, and here. What are these called here? No. So this right here is equidistant to A, equidistant to B, and equidistant to C. A, B, and C are called what of the triangle? Vertices. Everyone good? They're equidistant from the vertices. And I'm going to keep grinding here. 21. Who's got 21? Okay, in a triangle, I draw all three perpendicular bisectors. They will intersect at a point called the circumcenter. 13. 13. Once I find the circumcenter, I know it is the same distance from all three vertices. Any issues? All right, grab that compass and a straight edge because we can find the circumcenter using a compass too. All right, here's the gist of the problem. I'm in the kitchen. I got a stove, I got a sink, and I got a refrigerator in the kitchen. I'm going to build an island. And I want to make sure it's the same distance from those three appliances. Where should I put it? Okay, I got to make sure I put the island somewhere. I have no, obviously it's not going to be up here because that's not the same distance away. I got to put the island somewhere where it's equidistant from all 3 points. Everyone all right on my task for you? Doesn't the stove, kitchen, and refrigerator, those look like vertices of a what I could make? All right, let's do it. Grab your straight edge. That looks like I could do vertices of a triangle, KSR. And what have we been calling all today? That point that is equidistant from K, S, and R. What am I asking you to find really here? 23, what am I asking you to find? The circumcenter. I'm asking you to find the circumcenter. All right, let me keep going with somebody else. So if I need the circumcenter, 30, I'm asking for the intersection of all three what? Good call. 5, the intersection of all three what here for the circumcenter? Okay, now I got to review with you. How do I use that compass to do a perpendicular bisector on the side? Anybody remember this one? Say I want to do the perpendicular bisector for KR. Anybody remember how to use the compass to do it? Nope, not that one. Put your compass on one of the points and open it up more than half the distance. And yes, you want to make a decent size arc here. We used to call this one the fish. And then do what? Keep the compass opening the same. travel over to the other point, endpoint, and make the same arc so it intersects twice. And then you guys can grab your straight edge and draw in a perpendicular bisector. What do I still need to do? I need at least another one. One's not going to tell me where the circumcenter is. So pick another side and do the same thing. And yes, you will notice you're going to have a decent amount of construction marks. Leave them. Don't erase them. Let's do a new color for that one. Okay, I've now done 2 perpendicular bisectors. Is there a need for a third one? Is there a need for a third one, or do I already know where the circumcenter is going to be? Need for a third one or no? Nope. You can always do the third one just to check. All right, but if you're confident in your construction abilities, how's mine look? Around the same spot as yours? Because I don't use a straight edge here, but so it looks like our island's going to go right there. That point is equal distant away from the 3 appliances. And also remember, that's where I could put my compass point and draw a circle around it. All right. Questions from you guys here? Your first problem on tonight's homework, and we're not done with the notes, but first problem on tonight's homework, you are at the playground, you have a swing set, sandbox, and a slide. You need to put a water fountain that's equal distant away from each. That's what we're doing tonight, okay? That's what we're doing, locating the circumcenter. All right, we're going to keep continuing, but I'm going to forget to pass these out. On your assignment sheet, just to let you know, it goes through Thanksgiving break. Okay, so on Monday, I'm not going to hand one out for 2 days, so it goes right through Thanksgiving break. All right, next quiz is Monday. All right. Monday and Tuesday, we have school next week. Okay. So just whatever is left over, pass them forward. All right, moving on. 24. Anybody have 24? Or is that too high? Too high. 15. 15 in the house. Here we go. I have the circumcenter. It was formed how? The intersection of all 3 perpendicular bisectors. 23. I now have the circumcenter, Dylan. I now know it is equidistant from what? All 3 vertices. Everyone good? Because I'm moving on to a new point now. How solid do we feel here on circumcenter? Okay, because I'm going to do a new point now. So take your compass right now with me. And now we're going to do angle bisectors. Not perpendicular bisectors, angle bisectors. Ooh, how did we do that, right? So let's bisect angle B first. Put your compass point on angle B. Make an arc through angle B. Any more extra assignment sheets? Are we good? Go ahead and make an arc through angle B. Put your compass point on one of the points of intersection you just made. And make an arc above the first one. Keep the compass opening the same. Go down to the second point of intersection. Little fireworks action. And do the same thing for angle A up top. Just because of time constraints and messiness, I'm not going to have you do the third angle bisector, but predictions if I did. They would all intersect at the same point, right? So my conclusion here, what did you just construct again? What were these called? So in a triangle, all three angle bisectors are concurrent. So you first discovered today that the perpendicular bisectors were concurrent. And what was that point called they're all concurrent at? And then how we're ending class today is, hey, now you know all the angle bisectors are concurrent. So we need a special name for that point as well, right? So we had the circumcenter. This one now will be called the incenter. The point where the angle bisectors meet is called the incenter. Oh, whoa. We are far from done here. One, we talked about the circumcenter today. That was equidistant from the what? From the vertices. Everyone remember that. The incenter is equidistant from the sides of a triangle. All right, the incenter is equidistant from the sides of the triangle. So my diagram right here, I'm going to let you know point D is the incenter. Point D is the incenter, meaning it is equidistant from the sides. Name 3 line segments in your diagram that must be congruent then. Equidistant from the sides. 4, name 3 line segments equidistant from the sides. DE is congruent to DF. Perfect. I got 3 more questions and then we're out. 7. Who's got 7? Aaron. The incenter is where all 3 what intersect? Incenter. Angle bisectors. 21. All three perpendicular bisectors intersect at the circumcenter. My last question. Let's see if we can figure this out. You don't need to write this down. Let's say point D is the circumcenter Matt just talked about. It is the circumcenter. Name 3 line segments that are congruent up here if D is the circumcenter now. 20, let's finish this. If D is the circumcenter, name 3 line segments that are congruent. Hold on, no. That's equidistant from the sides. It's circumcenter now, which is equidistant from the what? Stop. So name 3 line segments now. Perfect. There we go. Perfect timing. You need graph paper tonight. If you want to borrow some before you leave, come on up and use it.